Hello everybody. Today we're going to be looking at standard form of a quadratic function. Standard form is just another way we can express some quadratic equations. We have two learning objectives today. We want to be able to identify and calculate key parts, meaning the vertex and the y-intercept of a parabola from standard form. And we're also going to want to be able to graph a parabola if it's given to us in standard form. Okay. This video will cover objective 1, and the next video will cover objective 2. You'll see that we have a little warm-up here. We're going to go ahead and ignore that warm-up. It works better when we are doing a full live class, and I don't think it's going to work out the way I would like it to in a video. Okay, so standard form is y equals ax squared plus bx plus c. Now we already learned about vertex form, but now we're going to learn about standard form. It's just another form, just another way we can write the equation of a parabola. One thing I'd really like to point out is that a, you'll see it is used again. That a is the same a as it was in vertex form. Okay? Okay. So, when I'm looking for the vertex in standard form, I can find the x-coordinate by using the formula x equals negative b over 2a. Then, to get the y-coordinate, I just plug in for y. So I'm going to substitute that x value into the equation, and I'll get y. Okay, so if I have y equals x squared plus 10x plus 22, I need to use x equals negative b over 2a. Well, if I have x equals negative b over 2a, my b is 10, right? I have a is 1, b is 10, c is 22. So I'll plug into the top of my fraction, negative 10, over 2, because that's what's in the formula. And there is no number in front of my x squared there, so it's 1. So x equals negative 10 over 2, which we should know equals negative 5. Easy enough. Okay, now to get the y value, all I do is I take that negative 5 and I'm going to plug it in to my equation. You need to be really careful and make sure that you're following your order of operations carefully here. Otherwise, you can run into some trouble. So negative 5 squared is 25. 10 times negative 5 is negative 50. And I have the plus 22. So that should give us negative 3 at the end of the day. So my vertex is at negative 5, negative 3. Very cool. One thing I want to point out, and it's not part of finding the vertex, but it's something we can do, is we can actually write this equation in vertex form with the information we have. If y equals a times x plus h squared, x minus h squared plus k, then I can just plug in my h and k, which are the coordinates of my vertex, and I can then just use the same a. These two equations are the same. They're the same representation of they're the same parabola represented in two different ways. So I'm going to prove to you that they're the same. I'm going to expand out that x plus 5 squared and double distribute so I can simplify. All right? This is not actually something I'm asking you to do. It's just proving to you that these two equations represent the same parabola. So I get x squared plus 5x plus 5x plus 25 minus 3. Okay, I simplify. I add my two 5x's together. That gives me 10x. I subtract my 3 from my 25. That's 22. Look at that. Those two equations are exactly the same. So that's going to be important for us for when we learn how to graph. These two equations are the same parabola represented in two different ways. Now, we're going to talk about the y-intercept of a parabola, and we can actually find it very easily when we are looking at standard form. if I have a y-intercept, as I drew here, that's where x equals 0. All right, if that's where x equals 0, I can plug in 0 to the equation. You'll see here, 0 squared is 0 times a is still 0. That whole thing cancels out. Next term, b times 0 is 0. Cancels out. So I'm just left with c. I don't have anything but c. So my y-intercept is 0, comma c. So my y-intercept of this equation is just going to be 0, comma 22. All right, guys, stay tuned for the next video. It will be on graphing. Thank you. Have a good one.